Yes.
So, good afternoon. We're gonna solve some more problems, but we just gonna go over the trigonometry ratios because as you realize, we use a lot of these trigonometry ratios to solve equations in physics. So, just to go over these ratios, when we talk about an angle. Of course, it has to be a right angle triangle. You have 90 degrees. So whenever you have the angle, you have to know which one is the adjacent side, which is the opposite side, and which is the hypotenuse. So if you're talking about this angle, the sine of this angle is the opposite over the hypotenuse. Okay, if you have a right angle triangle. This is the adjacent side. If you're talking about this angle right here, this is the adjacent side, this is the opposite side, and the hypotenuse is the longest side, right angle triangle. So the sine of this angle is the opposite over the hypotenuse. So the abbreviation is SO, sine opposite over the hypotenuse. And then if you're talking about this angle, this is going to be the adjacent, this is the opposite, and this is the hypotenuse. So the cosine of an angle is equal to the adjacent over the hypotenuse. So that is ka. So ka, to, or to. The tan of the angle, so if you're talking about this angle, this again is the adjacent, and this is the opposite, and this is the hypotenuse. The tan of this angle is the opposite over the adjacent. So you need to go over this and remember them, okay? And then you'll use your trigonometry calculator to calculate what's going on. All right, so let's look at this question. It says the diagram depicts a force that makes an angle to the horizontal. So whenever you have a force making an angle to the horizontal, you have to resolve the force into its horizontal component and its vertical component. Okay? Horizontal component, vertical component. Because this is what you call the net force. So you can resolve once it's making an angle to the horizontal, you can resolve it into its horizontal component and its vertical component. That's important. So essentially what you're doing is creating a right angle triangle. So for this force, if you're going to resolve it into its component, just as we did when we did inclined plane, and we resolve G, okay, so that would be the horizontal component, and then the vertical component would be straight up like that. Okay? So if you're going to resolve this force, this is the horizontal component, and then this would be the vertical component of that force. Okay? So which one of the choices below best depicts the horizontal and vertical component of this force? So the force is coming down like that. When you resolve a force that makes an angle to the horizontal, it's going to have a horizontal component. So the horizontal component has to go to the left because this force is going down like that. And then the vertical component has to go down. So the answer that best looks like this is D, right? The vertical component comes straight down, and then the horizontal component goes to the left. So you have to know how to resolve your force. You have to know a little bit of trigonometry. I mean, you already know your Pythagorean theory. So, okay, all right. So let's move on. All right. So let's read this question, and we're going to use our knowledge so far about force and resolution of force to see what's going on here. So there are three sailboats. Three sailboats are shown below. each sailboat experiences the same amount of force, yet has different sail orientation. There are different sail orientation. You have the wind which is coming this direction. So wind is coming straight down. Okay. The sail has different orientation, but it is subject to the same amount of force. The direction of the force is different though. So this is the resultant of the force acting on this boat. This is the resultant of this force acting on that boat. And this is the resultant of the force acting on this boat. The wind is coming in that direction. All right? Okay, so let's analyze what's going on. So the amount of force, so the length of the arrow depicts the amount of the force. So the amount of force is the same because the length of the arrow is the same in all three cases. However, the orientation of the force is different. The direction of the force is different. For this force, for this sailboat, the resultant force is like this. For this one, it is like that, and it's like that. Okay? So the question asks, in which case is the sailboat most likely to tip over sideways? In which case it is most likely to tip over sideways? So the wind is blowing in this direction. Okay? The resultant force is like this. Okay? So let's analyze. In A, the boat is going here. There's wind going there. The resultant force is on this boat is like that. So whenever you have a force at an incline, you resolve the force into its vertical component and its horizontal component. Okay? So the horizontal component of this force is what's going to drive it forward. Okay? So even though the resultant force is coming down like this, when you resolve this force into its component, you're going to get a vertical component which is coming this direction, and the horizontal component is going to take the boat forward. Okay? All right. So the vertical component is gonna the vertical component is fairly large, and the wind is coming this direction. So this boat could topple over. Let's look at the second one. So the resultant force is there. You resolve it into its vertical and its horizontal component. This boat has a fairly large horizontal component, so it's going to propel the boat fairly fast going to the right. The vertical component, which is in this direction, is not as great as this one. Okay? So for this boat to tip over, because the wind is blowing from north to south. Okay? So for the boat to tip over, you have to have a very large vertical component of force. And then in case C, this is a resultant. Okay? The resultant force, and when you resolve it into its vertical and its horizontal component, it has a very small vertical component, a very large horizontal component, which is going to drive the boat to the right. So for this boat to topple over, okay, it's going to need a very large vertical component to tip it over. So the resultant with the largest vertical component is case A. So this is the boat that's most likely to tip over sideways. Okay? So you just have to resolve the force, and you can see that case A has the largest vertical component as opposed to horizontal. So this boat is going to travel faster to the right because the horizontal component is largest here, and that's the horizontal component of this resultant force which is going to drive it to the right. It has a very small vertical component. This one has a very large vertical component, so it is most likely to topple over this way. Okay? All right. All right. Let's solve another problem. Okay? So in this case, we have a tow truck. So all right, let's see what we got here. So right. So we have a tow truck. If the tensional force in the cable is 1,000 newtons, and if the cable makes a 60 degrees angle with the horizontal, then what is the vertical component of the force that lifts the car off the ground? So this is so you have a cable attached to this tow truck, and there's a tension in the cable. It's going to pull the car upwards. So the tension is upwards. But this upward force going to have a horizontal component and a vertical component. It is the vertical component which is going to pull the car upwards. All right, so let's just complete. If we complete this triangle, so this is making a 60 degrees angle to the horizontal. The vertical component of the force would be straight up. So this is the vertical component, call it Y. And call the horizontal component X. This horizontal component of this resultant force is not pulling it up. The portion that's pulling it up is Y, the vertical component. So we can, the question asks, what is the vertical component? All right. So we know the hypotenuse is 1,000 newtons. Okay. We know the angle. This is the angle right here. All right. So let's use one of our trigonometry formulas. We know that the sine of an angle, we just went over it, the sine of an angle, sine theta, call the angle theta, is equal to the opposite side. Okay? So if it's this angle you're talking about, this is the adjacent side, this is the opposite side, and this is the hypotenuse. So the sine of the angle is equal to the opposite side over the hypotenuse. So if we want y, which is the vertical component of this the tension in the cable. So the opposite side, which is y, is equal to the hypotenuse times the sine of the angle times the sine of the angle. So sine of 60 degrees. Okay, sine of 60 degrees. So we said that the hypotenuse is 1,000. The sine of 60 degrees. So you take your calculator and you're gonna, all right, so let's look for that. So you take your calculator and you go to your trigonometry thing. So the sine of 60 degrees is equal to 0.87. So that would be, so our 0.87. So that would be 870. So that's equal to 870. Okay, so this vertical component that's lifting the car upwards is 870 newtons. Okay, 870 newtons. Okay, so the tension in the cable is at an angle. It is at an angle. Okay, so this force has a horizontal component and a vertical component. Once you complete the right angle triangle and you know the angle right there, you can calculate the horizontal component and you can calculate the vertical component. It's the vertical component that is lifting the car upwards. Okay, so you have to understand that principle. All right, so let's look at this problem. So in this problem, we all right, let's look at it. So read the question carefully and understand what's been asked. Consider a 10 Newton frame. So you have a frame, it weighs 10 Newton. It is held up by 3 different wire orientations as shown in the diagram below. So you can hang it so that the angle to the horizontal is 15 degrees. So you have two hooks, okay, and the angle to the horizontal 15 degrees. Or you can make it so that the angle to the horizontal is 45 degrees, or you can make it so that the angle to the horizontal is 60 degrees. Okay? So in each case, 2 wires are used to support the picture. So 2 wires used to support the picture. Each wire support 1/2 of the sign weight. So each wire is gonna, so the total frame is 10 newtons. So each wire is gonna support 5 newtons. The angle that the wire makes with the horizontal vary from 60 degrees to 15 degrees. So that's 15 degrees, 45 degrees, and 60 degrees. Use this information and the diagram below to determine the tension in the wire for each orientation. And when you finish, click. Okay, so you look at the answers. Okay, so for the first case, so we know that each of these cable is going to support a 5 Newton weight, right? The total weight of the frame is 10. So what you need to do is, okay, so this tension, the tension in this wire, let's draw let's draw them out. The tension in this wire, okay, so this wire is making a 15 degrees angle with the horizontal. So let's draw the horizontal. Horizontal, it makes a 15 degrees angle, okay, and then you complete your right angle triangle. So this is 15 degrees. 15 degrees. So the tension in this tension here, which is this tension, this force in this wire, you can resolve this force into its vertical component and the horizontal component. Okay? It is the vertical component which is going to support this 5 Newton weight. So each cable, so the tension here is 5. So this is 5. Okay? So 15 degrees, this angle, tension in the cable is 5. Sorry, not the tension in the cable, sorry. Remember, this weight is pulling straight downwards. The weight is pulling straight downward. So this 10 Newton force, which is going straight downward, has to be balanced by a 10 Newton force going upward. So it is actually the vertical component of the force that's going to support it. So this is not 5, it is this opposite, the opposite angle over here, which is 5. Okay? So this angle is 15. The hypotenuse. This is the tension. We don't know the tension in the cable. This is the tension in the cable. Because the weight is going straight down and it's 10 newtons, then the force going upward have to balance that force which is going downward. So the total force that's going to pull the frame upward have to be 10 newtons. And it's going to be sheared at 10 newtons between the two wires. So it is this vertical component of this force which is 5 newtons. So we can determine the tension in the cable. Remember, so the sine of the angle, this is the angle we're talking about. The sine of the angle is equal to the opposite over the hypotenuse. The opposite here is 5. The hypotenuse is the tension that we want to calculate. Okay? So the sine of 15 degrees, so the tension, just rearranging the equation, the tension in the cable is equal to 5 divided by sine of 15. Okay? Sine of 15 degrees. And the sine of 15 degrees is so when let's look for the sine of 15 degrees. So we go to sine and 15 degrees, that's equal to 0.26. Okay? So it is 5 divided by 0.26. And that is equal to 19.3. 19.3 newtons. Okay, so the tension in this cable is 19.3 newtons, but the vertical component, which is going to pull, the vertical component is up, is straight up. So over this side, the vertical component here, over this, the vertical component is 5 over here, and over here, the same thing, the vertical component is 5, because it has to balance the downward force. Okay, so the vertical component on both sides is 5, for a total of 10, because the weight of the frame is 10. But the tension on both sides is 19.3 newtons. Okay, and then you do the same thing for this one. So it's 45 degrees. Okay, it's a little strange triangle, don't worry about that. It's 45 degrees. The weight of the frame is still 10 newtons. So the vertical component of the tension is still going to be 5. because the weight of the frame is the same. This angle is 45. So the tension, using the same principle, the sine of the angle is equal to the opposite over the hypotenuse. So when you do the same thing, so the tension in this case is equal to 5 divided by the sine of 45. Sine 45. So you get 7.1. So 7.1 newtons. Okay? So we know the tension here is 7.1. The vertical component is still going to be 5. And then for this case, we do the same thing. We're resolving the tension in the wire into its vertical and its horizontal component. So this angle is 60 degrees. The vertical component is still 5 because the weight of the frame is still the same. So we just have to find the tension. And the tension in this scenario is 5 divided by the sine of 60. Use your calculator. Okay, so the sine of 60. So when you work that out, you get 5.8. 5.8. So the reason why the reason why we did this this example is to show you that a simple thing as doing stuff around your house, if you make the angle to the horizontal very small when you're putting up a frame, the tension in the cable is going to be very high. If you can make the angle to the horizontal larger, the tension in the cable is going to be less. So, if you have a weak cable, you don't want to be in this situation because the tension will be too much and it will burst the wire or cable. So it's best to make the angle to the horizontal larger. Okay. The important thing is to remember the trigonometry things. All right. So this is just what we just did a while ago. You know, the vertical component is that tension or that force that's gonna lift the picture. Okay, it is not the horizontal component. The vertical component of the force is going to lift it. All right. So the following picture is on a wall. You're going to use your trigonometric function to determine the weight of the frame. Okay. So we know, so this is 45 degrees, 45 degrees. So what you do, so this is the tension there. You can find the vertical component. So remember, it's the vertical components that's going to lift this frame. It is the vertical components that's going to lift the frame. So just use one side. So we can use one. Let's use this side. So let's draw it. So if we use this side, then this is the tension in the cable. And we're going to resolve the tension in that cable into its horizontal and its vertical component. Okay. Okay. So this is the tension in the cable. Just imagine a beautiful triangle. Okay, so this is the tension in the cable. And they told us that the tension in the cable is 30 newtons. 30 newtons. And this angle right here is 45 degrees. 45 degrees. Again, when you resolve the tension in the cable, because the tension in the cable makes an angle to the horizontal, you can resolve this tension in the cable into its horizontal component and its vertical component. So the tension in the cable, because it's pulling the picture up, it's going to go in that direction. The vertical component is going to be in that direction. Remember, it's the vertical component that's going to, sorry, it's the vertical component that's going to support the weight, okay? And the horizontal component is going to go in this direction. So let's use our trigonometric function. So we want to find this. So to this angle, this is the adjacent, this is the opposite. So we want to find the opposite. So we're going to use a trigonometric function to find the opposite. So sine is pretty good. So the sine of an angle, the sine of 45 degrees is equal to, this is an equal sign, is equal to opposite over the hypotenuse, which is 30. The hypotenuse is 30. So the opposite then is equal to, the opposite is equal to 30 times the sine of the angle. So you use your calculator and you look for the sine of the angle and you multiply it by that. So the sine of 45, the sine of 45 is, all right, let's look for the sine of 45. So sine 45, that's equal to 0.71. So that's 0.71. So that is equal to 21.2. 21.2 newtons. So that's the vertical component of this 30 is 21.2. But there are two cables. There are two cables, and each of them have a horizontal and a vertical component. So it's the vertical component of the two cables which are going to support the weight. So the weight of this frame is 21.2 times 2. So the weight of the frame is twice the vertical component in one of those cables. So it's equal to 42.2. Because there are two cables attached to this frame. Each of the wire, this wire, this wire has a tension of 30. This wire, same tension of 30. They have the same angle, so the vertical component is going to be the same. It is the vertical component, because remember, the frame, the weight due to gravity is straight downwards. The force due to gravity is straight downward. So you can only balance this by an upward force with the same magnitude. the upward force have to be the same magnitude. If it wasn't, then the frame would be falling or to be moving upwards. So the upward force has to balance the force due to gravity. And it's the vertical component of these, the tension in these cables, that's which going to support the weight of the frame. Okay? All right. Okay, so all right, so let's look at this one. So this is another problem. So let's see. It says the sign below, so there's a sign right here. The sign below hangs outside the physics classroom, advertising the most important truth to be found inside. The sign is supported by a cable and a rigid horizontal bar. So you have a rigid horizontal bar, and this is a cable. The sign has a mass of 50 kilograms. So this sign has a mass of 50 kilograms. Then determine the tension in the diagonal cable that supports it. I want you to determine this, the tension here. So determine this tension in the cable. Determine this tension. So the mass of the sign is 50 kilograms. So the downward pull, or the force due to gravity, let's calculate that. So the force due to gravity, I'll tell you what, all right, so this is tension in the cable, call that T. The force due to gravity, so it is the frame, okay, so the sign, the force due to gravity of the sign is the mass of the sign, which is 50 kilograms, times the acceleration due to gravity, which is 9.8 meters per second squared. 9.8 meters per second squared. So 50 times 9.8, so that's 50 times 9.8, that is equal to 490. So the force due to gravity, or the weight, is 490 newtons. So we know that this force due to gravity is straight downwards. It's straight downwards. The only thing that can support this is a vertical force going in the opposite direction. So it has to be the force that, so it has to be this vertical force, because when you resolve this tension, when you resolve the tension in the cable, you can resolve it to get a horizontal component and a vertical component. The only thing that's going to support this sign is the vertical component. So this vertical component has to be 490 newtons. So this side has to be 490 newtons. Okay? It has to be 490 newtons. So we know this angle. As a matter of fact, we know all the angles. This side is 490. So we can use trigonometry function to determine the tension. All right, so let's use this angle. We know that, let's use, we can use its opposite. So we can use sine again. You know, sine is very important. So the sine of the angle, in this case is 30 degrees. The sine of the angle is equal to the opposite. So if we're talking about this angle, this is the adjacent side, this is the opposite side, and this is the hypotenuse. The sine of the angle is equal to the opposite, which is 490, over the hypotenuse, which is the tension. That's what we need to calculate. So rearranging the equation, then the tension is equal to the tension is equal to 490 divided by the sine of the angle. Divided by the sine of the angle. Sine of 30. So, and that comes out to be, okay, so I think the sine of 30 is 0.5. So that will give you 980. So the tension in the cable is 980 newtons. Okay, so the tension is 980 newtons. The weight of the sine is going straight downwards. Only the vertical component of this tension is going to support this weight going straight downwards. So the vertical component is equal to the force due to gravity of this sine. Okay, so you just use trigonometric functions to calculate that. All right. All right, so we have another case. So, all right, so this, the following sine can be found in Glenview. The sine as a mass, which is 50 kilograms, determining the tension in the cables. So this sine has a mass of 50 kilograms. So, just use basic principles. The sine has a mass of 50 kilograms. So we can, first of all, we can determine the force due to gravity. The force due to gravity, which is pulling this sine downwards, is the mass times the acceleration due to gravity. So it's 50 times 9.8. And that gives us 490. 50 times 9.8. So that's 490 newtons. 490 newtons. Pulling, going downwards. So we have two cables which are supporting this sine. There's a tension here, there's a tension there, we don't know that. But what we know is that to support this sine, each of the vertical components have to be half of this. Each of the vertical components of this tension or this force have to be half of the weight of the frame in newtons. So for this tension, you can resolve this tension, well, tension is a force. You can resolve it into its vertical component and its horizontal component. So the vertical component is going to be half of the force due to gravity of the frame. So that's going to be half of 490 is what's that, 220, 245. So this is 245. So so it would be 245. Okay, but what they want to determine is the tension in the cable. So you know that this is 45. So you need to find the hypotenuse. So we can use sine again. Sine is very important. So sine of the angle, and if we're going to use this angle, 45, Sine of the angle is the opposite side. So sine of 45 is equal to the opposite side, which is 245, over the hypotenuse, which is the tension. So the tension then, tension is equal to 245 divided by the sine of 45. Divided by the sine of 45. Okay? So that comes out to be 245 divided by the sine of 45 is 346. So that's 346 Newton. 346 Newton. So the tension in this cable is 346 Newton, which is the same as the tension. Okay? The tension in the cable, 346. It is the, so when you already know the vertical component. So all you have to do is solve for the hypotenuse, which is the tension in the cable. All right? So all right, so all right, let's look at this one. So after its most recent delivery, the infamous stork announces good news. If the sign has a mass of 10 kilograms, so the sign has a mass of 10 kilograms, then what is the tensional force in each cable? So it's the same thing. The downward force is the mass times acceleration. So it's 10 times acceleration due to gravity, which is 9.8, and that equal to 98 newtons. Okay, so that is the downward force. Okay, now the tension is going to be, so you're going to have a tension in this cable that way, you're going to have another tension that way. So if you just use one side, you can resolve this tensional force into its vertical component and its horizontal component. Okay? If this is 60 degrees, then this is going to be 30 degrees, right? This is 30. We know that the vertical component of this tensional force is half of this. The vertical, because you have two vertical components, and the two vertical components gonna pull the weight of it's gonna pull the weight upwards. So each vertical component is half of this. So this is 49. So we know that is 49 newtons. So this vertical component is 49 newtons. So we know this side. So we can find this tension. The tension is the hypotenuse of this right angle triangle. So again, we can use our sine, the sine of the angle, sine of the angle. In this case, is a sine of 30 degrees. That's equal to, so no, we can't use sine because this is the adjacent. So this is the angle we're talking about. I mean, we could, okay. All right. So if this is 30, this is 90, this is 60. All right. So, so this is 60. right? So if we use this angle, so you can change it. I would have to use, okay, don't worry about it. So this angle is 60 degrees, right? So the sine of 60 degrees, now so the sine of this angle is equal to the opposite over the hypotenuse. So it's 49. The hypotenuse is the tension. So 49 over tension. So the sine of the angle, this angle, because this one is 30, this is 60. Sine of the angle is the opposite over the hypotenuse. We want the tension. So the tension is equal to 49 divided by the sine of 60. So 49 divided by 60. All right, let's look for that. So that's the sine of 60. So you look for sine, and then 60. That's 0.87. So it's 49 divided by 0.87. So 49 divided by 0.87. And that's equal to 56. Okay, so that's 56. So the tension in the cable is 56 newtons. All right, so this tension is 56 newtons. All right, and it's the same tension over there. Okay, all right, so we're going to do one more for completeness sake, and then you should fully understand that. So suppose that a student pulls suppose that a student pulls with two large forces, F1 and F2, in order to lift a 1 kilogram book by 2 cables. So this is the 1 kilogram book. There are 2 cables, and the cables make a 1 degree angle with the horizontal. Then what is the tension in the cable? Okay. So, all right. So again, you do the same thing. There's no trick in it. Okay. The weight pulling downward is 1 kilogram. So you convert that to newtons. So the force due to gravity is the mass times the acceleration due to gravity. So that's 1 times 9.8, which is equal to 9.8. So that's 9.8 newtons. 9.8 newtons. Okay? So that's a force pulling downwards. So if we complete, so the tension here is that, so the tension is like that. Okay, so if we complete this triangle, we're going to resolve that tension into its horizontal and its vertical component. Okay, so just imagine that this is a triangle. Okay, this is the vertical component. This is the tension. The angle right here is 1 degree. Very tiny angle. So this is 1 degree. Okay. What we know, since the force pulling downwards is 9.8 Newton, each of the vertical component of these two tensional force have to be 4.9 Newton. So this is 4.9. 4.9. So the vertical component at each side have to be 4.9 Newton. Okay? We don't know the tension. The tension here is F1 and the other side is F2. All right, so this tension is F1. So we can calculate F1 using our same sine, okay? The sine of the angle, so the sine of 1 degrees, the sine of the angle, so sine 1 degree is equal to the opposite, which is 4.9. That's the vertical component of your tension. 4.9 divided by the hypotenuse, which is F1. So F1, which is the tension, is equal to 4.9, okay? 4.9 divided by the sine of 1 degrees, sine 1 degree. And that is equal to, all right, so let's, sine of 1 degree is, all right, so 4.9 divided by sine 1 is 281. So that's 281 newtons. Okay? The reason why we did this example is to show you that if the angle is this is just a 1 kilogram book, you know, and the tension that you have to use is 281 newtons to lift this 1 kilogram book. The simple reason being that if the angle is so low, once you increase the angle, then it's easier to lift the book because the vertical component is going to be greater. So what I mean is if you make the angle very, very high, then the vertical component is going to get greater. And it's this vertical component that's going to pull the book upwards. When it's very close to the horizontal, the vertical component is very, very small. So you know, it's not going to be enough to lift the book unless you have tremendous amount of uh, tension. Unless you have tremendous amount of tension in the cable, it's not going to lift the book if the angle between the horizontal and the cable is not very large. But when you have a large angle between the horizontal and the tensional force, the vertical component is large, so it will more than lift, you know, objects. It's the vertical component of these tensional force that's going to lift objects. All right. So that's the rationale for doing this problem. So we're going to stop here, and the next time I think we will do Newton's third law. Okay, we will do Newton's third law. So let's